Mr. Kumar, can you hear me? So
I can hear you. Yeah.
yeah. So we can
Perfect.
also see, your video is fine and we can also hear you. I think it's 3 and now we are actually ready to start our webinar. A very warm welcome to all our attendees and all our speakers, and welcome to this webinar on building AI-ready data centers, where we're going to focus on requirements, challenges, and solutions. My name is Akanksha Mahajan. I am Director Research with Indian Infrastructure and also oversee the editorial operations for Tele.net. I'm here with my colleague Sarthak Takyar, who is a senior research analyst with our research team and is here to support me. I will mostly be moderating this session. Before I actually talk about the structure of today's webinar, I just want to spend probably a minute and a half or less on quickly introducing the background with which we've organized this webinar today. As most of you are aware, Indian data center industry is transitioning to next generation AI ready capabilities fueled by the growing AI adoption across enterprises. The surge in AI workloads is pushing data center operators to redesign this infrastructure, and they are looking for support for higher power density, advanced cooling systems, bigger network loads, and faster interconnects. On the network side, also architectures that support high speed, low latency, and secure transmission for real-time applications will be very, very critical for successful AI integration. With that as a background, the mission of this webinar is to identify the key requirements of new age data centers, discuss key issues and challenges, highlight design best practices, as well as talk about emerging network and technology solutions that can support data centers in managing AI workloads. I'm very happy to announce that we have a diverse set of speakers here, representing the data center operator community, as well as, the end users, banking organizations, and system integrators like HPE, who will be sharing, their contribution, their role, as well as, their way forward to this entire evolution of AI that the data center, landscape is witnessing. But before we dive deeper into the panel, I have here Mr. Abhishek Verma from Belden. He will be doing a short presentation, basically to set the context and also, tell us a little about how AI is impacting the data center landscape. Mr. Verma, welcome. I will just take about 20 seconds to introduce you to our gathering here. And, once we start the panel, gentlemen, I'll be introducing the rest of the panelists before the panel. So for everybody's, advantage, Mr. Verma, as I said, is representing Belden here. He is RCDT Senior Solution Consultant at the organization. He comes with more than 15 years of experience and specializes in designing complex projects and implementing emerging technologies across smart buildings, data centers, hospitality, healthcare, campuses, and other networking requirements. Today, of course, he'll be telling us more about, Belden's solutions in the AI space as well. Over to you, Mr. Verma, if you can please share your screen.
Thank you, Akanksha, for such a nice introduction. Let me just quickly share my screen, put it on presenter mode.
Yes.
Perfect.
Yeah. So we can see. Please go.
All right. So first of all, thank you everyone for joining this webinar. We will start with a short presentation. It's getting shorter and shorter. Now I have only 15 to 17 minutes to close this. So I'll move a little fast and we'll have the question and answer session probably once I finish my presentation and later on during the panel discussion. So I'll keep the agenda like this. We'll quickly have 3-4 slides for the industry forecast and a couple of slides for the India DC market overview. Then we will move to the standard design, the cabling design for the AI data center with respect to the MPO pre-terminated solution. Then we'll move to some of the challenges we think are there important to understand and some recommendation from our side. And then in the end, why and how Belden can support to build a AI data center. All right, so this slide shows basically how the Ethernet speeds have grown over time and where they are headed actually. Now, if you look at the left graph, we started with just 10 Mbps in around 1980s. We moved to 1 gigabit per second around 2000, then we moved to 10 or 40 gig around 2009, 2010, 11 kind of, a time. Now we are talking about 400 Gs. And not only that, we are actually talking about 800 and higher. We are pushing 1.6 Tbps, and we already have people designing solutions for the 3.2 Tbps, which is already there for the forecast. What really important thing is how the adoption of the speed is happening. On the right, if you see, the figure shows how quickly a new product that is ramping to 10 million units in a annual shipment. So the 100 gig optics, it took around 10 years to reach to the value, whereas the 800 gig optics will take around 4 to 5 years, and we are expecting that 1.6 Tbps optics will take under 4 years to reach this humongous value. Now, this tells us two things. First of all, the demand for the bandwidth is increasing like anything. And secondly, the new technologies are being adopted, which must faster speed to keep up with the cloud, AI, and the more data intensive applications. Now, this slide talks how data center power capacity investments are expected to grow over the next few years. Now, on the left, you can see that overall spending rise sharply from around $400 billion in 2022 to nearly around $750 billion by 2028. It will go near to that value. And the breakdown on the right shows basically the breakdown of these things on the right, which shows where this money is going actually. Still, the IT infrastructure like servers, switches, storage, that remains the largest chunk, which is growing at a CAGR of around 21%. Now, what's interesting in this growth is the supporting system. The power distribution is growing by 18%. Thermal management is growing by around 17%. Even the power backup is growing by 10%. Now, this tells us that as IT loads get heavier and heavier, bigger and bigger, which is mainly driven by the AI, the cloud, the edge computing, and the data center also need a significant investment in cooling, in power reliability, in rack infrastructure. So the story is not about having more IT gears. It's about building a balanced ecosystem where the power, cooling, and the physical infrastructure, it needs to keep pace with the demand of the compute. Now, this slide highlights the top CapEx spender in the data center space, and it really shows the impact of AI on the investment. The top 15 service providers spent around $145 billion in 2023, and that's projected to jump around $266 billion in 2024. That's around more than 80% YOY growth. Now, if you look at the chart on the right, you can clearly see that Microsoft and Amazon are leading this chart, and that is followed by Google and Meta, and all of which nearly double their spending in 2024, around more than 94% YOY growth. Now, on a broader scale, the global data center capex in 23 was around $325 billion, and it is expected to reach to around $466 billion in 2024. And that is largely influenced by the AI server investment. Now, what's more important is that these top service providers will account for more than 55% of global capex for the 2024. And that is higher, more than 45% as compared to last year. So the key takeaway I would like to say from this slide is that AI is not just reshaping the workloads. It's fundamentally, it is driving a massive new investment with hyperscalers like Amazon, Microsoft, Google, Meta. These are basically leading the ways. Now the India data center market. So India is still is one of the fastest growing data center market across the world. Currently in India, we have more than 130 DCs operational, and that account for around 12.5 million square feet of area, which accounts from around 1.1 gigawatt of capacity. Well, the announced data center are more than 35 in next upcoming couple of years, which will account for around 5.5 million square feet and around 0.9 gigawatt of capacity. Top location still remains Hyderabad, Bangalore, Delhi, Chennai, Pune, and Mumbai still leading the way. Emerging locations, you can see that Ahmedabad, Delhi NCR, the Noida and Gurgaon region, and Kolkata is also coming up. On the right, you can see some of the locations where what is the current status for some of the operational data centers and the upcoming data center in terms of capacity in megawatt. India surpassed China in population in 2023. India is expected to reach to the third largest economy by 2027, and we still have more than 1.5 million American, firm staffs in India. This leads to a conclusion that India's data center market and India will be looked as a place where the opportunities will be there in future, especially from the DC perspective. Now, what are some of the strategies which has been taken by India? Indian government have recently announced a quite substantial investment of 1.25 lakh crores to develop a semiconductor ecosystem in India. We might have seen some of these projects or heard about it, the Tata PSMC chip foundry. That's basically in Gujarat, where there was more than 90,000 crore investment. And this is India's first commercial semiconductor fabrication manufacturing plant. And then there is Tata OSAT, that's again in Gujarat. And a couple of locations are also coming up. That is basically to help the fabricator to provide a place where there's some stringent testing and packaging can happen, which they do not have the in-house facility. And there are also some collaborations which are going on the market, which is going to support these strategies. All these projects is basically going to help India to reach to a place in globe where we will be having a semiconductor manufacturing, places, and we can be a global partner in the value chain for this. All right, that's it. Let's move to some of the AI DC design cabling, which we think is important for us to understand. First of all, when we talk about the AI data center, we know that there are three phases in the AI perspective. First is the data gathering, and then is a deep learning phase, and then there is a AI inference phase. Inference is when the model is trying to start communicating with the outer world, and when they get the input, they go back to the deep learning phase and then again come back and communicate with the external world. Now, when you go to the backend, when we say backend is like a backbone of this entire data center, there are multiple connectivities which are there in the white space of that area. Now, assuming there are multiple racks and in one rack there are 16 GPUs. So on one GPU, there will be at least one link for the MPO8, MPO is multi-push-on connectors, which are pre-terminated connectivity per GPU. And if there are 16 GPUs, there will be 16 MPO8, and there will be at one CPU, so two connection for that. If you check that, there will be around 144 fiber links, which will be coming to each server rack. If there is a row and there are 16 to 20 racks in that row, in that aisle, you will have more than 2,300 links coming from that row to the leaf rack. On the right, the orange color racks are basically represent the leaf rack. The leaf rack will have the same amount of links going to the spine rack. And the spine rack will have uplink and downlink with respect to the link in the spine rack itself. So the idea is, when we talk about the AI data center, the cabling infrastructure plays one of the most crucial role. How we are designing it currently, whether we are planning it for the future expansion, scalable, that's the most important part. We also have to make sure, like in the earlier slide, we have seen how the new technologies are coming, how the speeds are increasing. So the overall design of a data center from the perspective of the backbone plays a very important role for when we are designing it. Some of the challenges which we think are important to understand. First is a rack port density. This is something which we do not think generally, but we think is one of the most important part. How many ports or the connectivity you can do in that limited space of the rack? So you have a 45U rack, you have a limited dimension of the rack. The more denser you want to make a rack, it means the more difficult for the cool air to come inside. The more denser you try to put, it means the more difficult to trace or to find which port is connected where. For this, there are solutions, of course. So there is a like ultra high density solution you will find where you will have 144 fibers in one rack unit of space. So that is quite a solution which we have. But when you have these kind of solutions, how you are able to understand when you are trying to identify the ports. So for example, you have a copper panel, which is 48 port 1U, and you have multiple copper panels. It is very difficult to read the labels. It's very difficult to identify the ports, which port of panel is connected to which port of the GPU or the switch, or maybe in the aisle of that particular row of the rack. So there are solutions like traceable patch cords. The traceable patch cords, basically both ends, there is a LED on the connectors, and there are buttons on both ends. You press one button, both ends will start blinking for 15 to 20 seconds. So you just go and press one button, the other end will start blinking. So you can easily check which port is connected where. There are solutions for this in which, as per the standard rule, whenever you are putting a panel, there has to be another horizontal cable manager to manage the patching so that the dressing is better. For this, we generally go for angular panel, which is V-shape. Now, V-shape angular panel cannot fit in a closed rack because it hampers the door to close. There are also solutions available which we have, like the panel is straight, but modules are angled. So you can easily have the functionality of an angular panel along with saving the space for horizontal cable manager per rack unit. So basically, you can have a much higher port density with respect to these solutions as compared to the standard connectivities which are there.
Mr. Verma, sorry to interject. We have about 5 more minutes.
Okay, all right, okay. The second challenge which we see is the selection of the cable media. Now, this is second most important part. When we talk about the data center connectivity or the backbone, we talk about the losses. The lower the loss, the better, and based on the bandwidth and the distance it support, we generally go for optical fiber cables and connectivities. The more field determination we do, the more losses it will have. So most of the time we go for a pre-terminated solution. So MPOs are one of a solution for fiber, where is a pre-terminated solution, just plug and play. You have copper solution also in the pre-terminated solution with that. Apart from that, you will be seeing people using AOC and DAC cables. Another thing to know is that there is a small shift which is happening from a multi-mode fiber to a single mode fiber in the data centers. Generally, you will find more multi-mode in the data centers, but because of the decrease in the difference of the cost of the optics between the multi-mode and single mode, people are preferring single mode cable for that because it has much higher bandwidth and almost unlimited distance as compared to the bandwidth perspective. The third challenge which we think is about the workload. This is more related to the heat dissipation. I'll go a little fast from now. When I say heat dissipation, how much the heat is dissipated from the rack? There are multiple ways to handle that. One of the way is, so the traditional way what we do, like cold aisle containment or hot aisle containment, or even rack containment, cannot fulfill that requirement. In an AI data center rack, you will find a heat dissipation more than 30 kilowatt, it reaches up to 100, even higher. So there will be a combination of different kind of solutions. It will be a containment, and also there could be a liquid cooling, a liquid to air cooling, or liquid to liquid cooling, or immersive cooling option. And the last challenge which we think we wanted to put is the rack space availability. So because of the standard design of the rack, there is a limitation of how many devices you can put in the rack based on the height, based on the dimension. But the AI servers and the networking devices has a deeper depth, has a more devices you put in the rack. So the rack which should be implemented at the white space or white floor area of the data center, it should have the capacity of handling the load. It should have little higher rack unit. Of course, the height of the ceiling needs to be increased. It should be minimum 1200 mm depth and minimum 100 mm width, so that the more cable management can happen there. With this, we'll come to the last part of the presentation. Why Belden, of course. Belden has a legacy of manufacturing product for the mission critical communication application. We have more than 123 years old experience in terms of making these products for the industrial and the enterprise environment. We are there when there were multiple innovations was happening. Thomas Alva Edison used to have our fire and cable for experiment. The first TV broadcast which happened was on Belden cable. The Apollo mission, World War II, the first Ethernet communication which happens when it was coax cable. All these were, Belden was there playing its part and its role. We have multiple industries to serve, and data center is one of a main industry where we have the focus. When we say smart infrastructure, there are multiple buildings in it, and data center is one of the most critical part in it. We call it a mission critical application from that perspective. We can say any infrastructure is smart as long as you are providing a solution which does not handle only the current requirement, but also it should be able to handle the future application requirement for that. So basically, we say we have a complete solution from the rack space to the parking space. When you say rack space, I'm talking about the white space area where you have the racks, the high density solution for copper fiber, pre-terminated solution, pathways, PDUs, and all these. When we go to the gray space area, all the cables mainly related to the BMS, BAV, HVAC system, lighting control, or the instrumentation cable. You move to the parking area, the cables and connectivity for the sensors. All these are available with us. So the holistic solution approach is what we have, and we provide a solution for data centers. We basically divide our portfolio in two parts. One is active and second is a passive. On the left side, you can see the brand which we have for the active. Hirschman is a brand which itself has more than 100 years old experience in terms of industrial grade switches and connectivities, software, wireless solutions. We have NAC solution, we have protocol converters. On the right, you can see the cable brand we have. PPC for the broadband and GPON solution, Belden itself, and the Alpha Wi for industrial. We have more than 30 manufacturing plants across globe. Some of the plants are in India. One is in Pune, which is at Chakan, around 10,000 square meter of area. Overall land area around 24,000 square meter. There's a one Belden plant where we're making multiple cables and connectivities and switches, industrial grade and enterprise grade switches there, along with some of the industrial Lombok automation connectivity. There's a phase 2 also coming up in which we will have a 5-story building where we will be having we'll be expanding our manufacturing capacity in Pune. We have one more plant in Cochin, that's for PPC plant, where we are manufacturing broadband cables and connectivity solution for the GPON or FTTH application. We have a Belden tech support team in India that's basically handling the global requirement. That's L1 and L2 support team. Generally, you'll find a tech support team, especially for the active like network devices, but we also have a support team for the passive. So if there is any requirement for any design for any passive requirement, with say infrastructure, it's a data center, or any infrastructure building coming up, the request can be sent to us. There are multiple ways with a phone number or a ticketing tool, and our team will revert accordingly on that. We also have an R&D center here in India. That's in Pune and Gurgaon. The R&D center, because that's near to our, in India, so we have a good leverage of developing product. We have done multiple products which we did not have earlier. When the customer requested for a particular solution, for example, the MPO connectivity, they wanted a high density solution. So we get back to our R&D team. They worked with us. We discussed with consultant customers, and then we could later on we develop that solution for them. So that is available here. We have Customer Innovation Center. There are 5 CIC centers across globe. One is in Bangalore. CIC Center is a place where customer can come. They have the requirement. We will set up the entire requirement of theirs live in front of them. They will have the live demo. They can do the POC. They can do all the tests they want live in front of them before going to the site and implementing to that place. And this will be the last slide before I play a small video. How do we engage? So we have a team of consultant in which, and the consultant will be a single point of contact for customers or partners. He will be managing the requirement of customer. He'll be meeting the customer, trying to understand their current and future need. If required, he'll go back to the product team or to design the solution to them, do a POC, ask them to come to our CIC office, feel of the product. Once the solution is designed, we have a team which can support during the implementation part, and we also have a team which can support after the implementation, post-sales part of it. All right, I have to go a little fast. This is going to be the last slide. Next is small video, and then we will be going ahead with the panel discussion.
So much in modern business and life depends on the flow of information. As that flow grows in speed and sophistication, new challenges come into focus. From setbacks like signal loss, extended downtime, or a security breach, to complexities like managing disparate networks, fragmented data. Beyond these misconnections, untapped opportunities. Belden is your bridge between them. We connect people information and ideas to help you find clarity amid the chaos. Unlock untold possibilities for your business. Our complete connection solutions serve automation and smart infrastructure customers across a range of industries, from healthcare to hospitality, manufacturing to mass transit, and many others. Connections that are vital, connections that inform, connections that inspire, connections that enable increased productivity, improved experiences, and make digital transformation a reality. A safer, smarter, prosperous future is just within reach. When we make the connections, we make it possible.
All right, Akanksha, let's
Thank
over to
you. Thank
now.
you, Mr.
Thanks, Tom.
Verma, for setting the context. I can see a bunch of questions, but what I'm going to do is we will, deep dive into the panel first, and then, we'll probably take all the audience questions together. In the meantime, I'll just request the attendees to keep posting their questions, and we would just see, how and when do we take that. With that, I'm now opening the panel. Very happy to have Mr. Girish Thable, Mr. Ranganath Sadashiva, Mr. Rupesh Kumar, and Mr. Saurav Gupta to be joining us here. Mr. Bakshi was here a short time ago. I think he's going to be joining back. He's facing some connectivity issues. Gentlemen, with your permission, I'm just going to take about 40 seconds here to introduce each one of you for our attendees, and then, we will start with the first round of questions. So let me start with Mr. Dhable. Mr. Girish Dhable is Senior Vice President at Nextra. He comes with more than 25 years of diverse experience in the IT industry, telecom, data center, and cloud space. He is responsible for creating and implementing innovative data center technologies, ensuring quality assurance, service management, risk management, and operations. In his previous assignments, he's worked with SIFI, Tata Communications, Amazon Web Services, and Reliance Communications. Very happy to have you here, Mr. Dhable. We've intensively collaborated with you during your SIFI days and look forward to do that in Nextra as well. Mr. Dhable is joined by Mr. Rupesh Kumar, who is Senior Vice President, Head Data Center Projects at SIFI Technologies. He comes with over 25 years of experience in data center engineering, operations, and innovation. He has successfully led major hyperscale and edge projects across India. Currently, he's driving the development of AI-ready, sustainable, and future-proof infrastructure to meet the evolving needs of the digital economy. Welcome, Mr. Kumar. Very happy to have you here. We also have here with us Mr. Ranganath Sadashiv. Mr. Sadashiv is Chief Technology Officer at HP Hewlett Packard Enterprise India. He comes with over 30 years of experience in the IT industry, spanning engineering, technology, and management roles. At HP, he leads the technology strategy and vision for India, delivering cutting-edge solutions and services that address the evolving needs and challenges of customers across sectors. Welcome, Mr. Sadashiv. Very happy that you could join us today.
Thanks,
We
Akansha.
have here with we also have here Mr. Saurav Gupta. Mr. Gupta is representing Belden here today. He is Solution Sales Director, Smart Buildings and Data Centers for India and South region. He comes with more than 20 years of experience, has led multi-million-dollar transformations for leading organizations including IBM, Siemens, and now Belden, where he spearheads the connectivity portfolio across the India and South region. Very happy to have you here, Mr. Gupta. Well, I will be introducing Mr. Nama and Mr. Bakshi as they join the panel. So, the first round of discussion is going to be around what you think are the key forces that are guiding this shift to, AI infrastructure, and also, specifically from Mr. Kumar and Mr. Dhable, if you could tell us that at your respective organizations, what kind of initiatives you are taking, towards this. Maybe we can start with Mr. Dhable first, and then we'll probably come to it.
Hey, thanks, Akansha. Thanks. And thank you, Mr. Kumar. Because I always used to call him Rupesh. So when you say Mr. Kumar is joining, so I may not able to understand who is Mr. Kumar.
You are wondering who is that, right?
Okay, great. Okay.
Thanks to good to see you, Girish.
Yeah. Good to see you, Rupesh. Okay, great. So, Akanksha, see, basically, I like to take today's session in the interest of time on the cooling of the AI built data centers, because currently I'm working and doing a lot of research on that, and working on a white paper also, and very soon I will publish that white paper on telnet as well. So see, basically we have seen in the conventional data centers where typically we have seen the cooling from underfloor, or which is the fan wall units, okay, which is generally typically serving to 200 watts per meter square degree centigrade. Okay, but now when we see that the GPU load is increasing and the demand is increasing, the cooling technologies is also revolving, it is innovating. Okay, and recently we have seen multiple types like RDHX cooling or direct to chip cooling, and also the immersive cooling. I want to just throw some light on direct to chip cooling, which is I see that taking a little ahead a step in making the technology and making the GPUs available as AI data centers. And this is coming with two separate technologies. One is called as a micro channel with recess, and another is called as a micro vective. Okay, so now these two technologies which I'm researching, I'm working on how to make it available at the data centers, and what would be the operational challenges, because this is first time, or I have seen that many data centers are talking about that they have the AI load, but I really don't see that what kind of operational challenges and what kind of operational best maintenance practices they are following over there. And hence I said that white paper what I'm working should be useful in terms of the design projects as well as in the operations. Now coming back to how these technologies are evolving to meet the AI ready data centers across the globe, and especially in pan India. Just to give you the perspective on how these cooling technologies are coming is, as I mentioned, that from the conventional cooling, the first step which has been taken is the cold plate. In the cold plate, we have seen around 2000 watts per meter square degree centigrade is kind of a cooling which you can achieve. But can we achieve the requirement of the GPU? No, because in this case, you can have one or two GPU stacks, which is equivalent to 40 kilowatts per rack of the IT load. But when we talk about the AI load, we are currently working on 200 or 250 kilowatt per rack, which is immensely high. Okay, to meet such kind of a requirement, there are different innovations which are happening, and in that one is direct to chip cooling. And in the direct to chip cooling, what has been seen, that if I go with a micro channel kind of a cooling, then I can achieve around 11,000 watts per meter square. But when I talk about the micro vective of kind of a cooling, micro vective is nothing but the jet sprays on the chips. We're using the fluorochloride liquid, and it is targeting to the hotspots on the chips to directly drive away the heat from the hotspots outside. Okay, so that is microvective. There we can achieve 1 lakh watt per meter square degree centigrade of the cooling. Now let us look at what could be the challenges which we will see in the design, which we will see in the operations and the projects. See, this requires a very clean environment. Point number one, we don't have a very deep knowledge about the characteristic of fluorocarbons. We don't have aware about how the flow management, pressure management, temperature management will be carried out. Okay, so what could be the risk during the project phase? The risk can be that little impurities which can get introduced during the installation of the system can completely hamper the entire installation of the AI load. Second thing is the challenge which is getting debated at a very global level is, we talk about AI, we talk about 200 kilowatt per rack, we talk about 250 kilowatt per rack. But is that load is going to be constant? No, that load is going to vary. and that load is going to vary from suddenly by maybe 50 kilowatt to 200 kilowatt, or 50 kilowatt to 150 kilowatt. How you are going to manage the entire liquid system to do the proper cooling and variation into that, that is going to be a big challenge. And that challenge will coming to the designs and the projects, that how we are going to synchronize and align to the heat load. And the last but not the least is the operations, because we are talking about the micro channels, which are, or it is the jet spray where the pores are there, okay, or arrays are there. Now in this case we are talking about such as nano level channels and recesses, which you have to manage on the top of the chips. So if we fail in meeting the pressure or the flow, that could cause the leakage of that liquid and catch damage the entire servers, or any impurities in the system can choke up, or any bio growth within that channels can cause the major problems. So this system will come with a very high level of filtration, and how to maintain that filtration, what kind of best maintenance practices need to be followed, how that thermal management will be done. This is something which is a very interesting topic, which is a very interesting to understand, and a lot of research is going on. I am also trying to collect a lot of data, and will be happy to share that white paper with Telnet into your magazine very soon once I am completing. So that's I want to throw on the cooling technologies and the AI related designs
Yeah.
and projects
Uh,
that are coming with the
Thank you, Mr. Dhavle. I'm going to move to Mr. Kumar now. And Mr. Kumar, we know that SIFI operates some hyperscale, level facilities which are also AI ready. One, I definitely want your perspective on how, with the onset of AI, as a DC operator, what all things have changed for you, what kind of requirements have changed, and what has been your experience, and how are you preparing for that scalability that, would be required as AI gets more massified and, commercialized.
Yeah, sure. So, just adding to what Girish said also, and the whole industry, I mean, all of us have been seeing this growth in the last 25 years, So, what happened is that the data center industry was kind of supporting or running in parallel with the IT industry, because ultimately the data centers are going to support the IT hardwares, right? Because the data centers are going to provide that environment for the IT hardware to sit and operate and then provide the required performance. So it was kind of a parallel growth which was happening. So IT industry was kind of, or the hardwares were kind of evolving, and then data center was, walking along with that. Maybe I would say that the whole thing can be divided into two phases, the pre-COVID and the post-COVID era. Because till COVID, we have seen that it is kind of a very steady, consistent growth, right? And the early 2000s, when the cloud computing came, so we didn't see that kind of a very rapid or very surge in the computing requirement also, though it was there, but it was not that very great. But look at this. After COVID, we are seeing it's a very I mean sharp jump which has taken, right? So the kind of power consumption per servers what we are seeing now is nowhere what you have seen 10 years back. So I still remember, I mean, we used to say that a 5 kilowatt rack was kind of a high density rack in a few years back, but now that is not the case. Even 50 kilowatt rack is not called as a high density rack now. So that's a kind of a changes which happens. So what happened is that when after this, the COVID, when there was a kind of a huge surge on the demand due to various reasons, that is the thing what you're seeing on the digitization part, the UPIs, the 5Gs, Edge, and OTTs, and so many things, right? The kind of a surge happened on the computing. That is kind of made all service providers like us to kind of rethink our strategy and the way we are designing our data centers, which can support these kind of, the IT growth. So what we are seeing now is that the kind of or the AI workload which needs or which is kind of predominantly built around the GPUs, we are seeing that the demand is definitely increasing, but then I would say that it has kind of two parts due to the availability of all the GPUs. So we are seeing that still the air cooling is kind of leading this game in terms of, but then it is not the earlier air cooling. This is very much advanced air cooling, right? So earlier, what we used to cool around 10 to 12, we are talking about the air cooling, the complete air cooling systems or the HVAC system supporting around 40 to 50 kilowatt of rack capacity in the data centers. And the parallel stream which is happening is the liquid cooling, what Girish has clearly explained. That is another thing which is happening where the above the 40 or 50 kilowatt kind of an IP hardware, where it needs very advanced cooling technologies to handle kind of a GB200 kind of a servers that would need around 125 plus kind of cooling requirements. These are the two major things happening at this point of time where the AI adoption using the GPU technologies are actually having two parallel streams. One is the air-cooled thing with a very high density compute requirements, and the liquid-cooled system, which is having a very high requirements. So as a service provider, we looked at four aspects, and then all our facilities and I mean all the data centers in the world actually are looking at four aspects to kind of support these growing AI workload. One is the space, where I say about the building that meets this kind of specification, like whether it is a load bearing capacity of the floor or the height of the floor and those kind of things. And of course, next is the power because definitely these requires more and reliable power. And then the cooling, as I mentioned about the two types of cooling, which is currently very active. And then of course the network. So Belden has clearly explained the kind of growing requirements in network side. So these are the four aspects which all the service providers are currently working on to support this growing AI workloads.
Thank you, Mr. Kumar. Maybe the next round of discussion we would do around networking, but let me go to Mr. Sadashiva first. And Mr. Sadashiva, we can hear your remarks in terms of, HP's standpoint and how are you looking at, AI-ready data centers?
Yeah, very important to recognize that AI has created a ripple in the market space. It's like imagining a pond that had nothing at all, and there came AI, and a stone was thrown into the pond, and it has set a lot of ripples in the way we actually look at our lives itself. And HP happens to be at the center of this. When you say data center, we essentially look at how do you handle data across its life cycle. We also look at how do you compute that data, and then also look at how you connect all of those devices together. I frankly see that there is a shift in the overall architecture. If you were to look at the pre-COVID eras, as mentioned, we were talking of cloud-native architectures, which are web services oriented. There were multiple workloads, and there were many nodes which catered to that. But if you were to look at that workload itself, the characterization of the workload is very different. If you look at AI native and AI model workloads today, it's essentially one workload and thousands of nodes that are essentially working together. And if you were to look at the overall architecture of it again, you typically thought of a multi-cloud architecture, which perhaps is a hybrid by design kind of an architecture today. So, there is a foundational change in the way we look at our entire data center, and the data centers have to be re-architected to ensure that you're able to handle the kind of AI workloads that we see. And that AI workload itself, is characterized by various stages in which you look at these workloads. If you're essentially doing a lot of training, you need a lot of compute capabilities, a lot of data, and those are the model builders that we see. And then, if not, you're essentially seeing at interfering, rather inferencing of several of these models and the algorithms that are there. That's the kind of workload spread that we see. Also for from an India perspective, I think the overall initiatives from the government and from enterprises have seen that they are moving away from traditional kind of setups into an AI centric setup. Most applications today incorporate AI within them, and the many of them who have large volumes of data are looking at harnessing the data for insight, which means that it's AI enabled. Those are the things that I see. But of late, in the last 12 to 18 months, I think there is a bigger and a serious sense of approach from enterprises to look at artificial intelligence. A large part of it was a lot of POC doing, and understanding how this can really benefit organizations, which was done using hyperscalers perhaps. But now they realize that AI is mostly a hybrid kind of a workload and depends largely on the data that you have. So the more data you have, you want to harness that for your benefit. So people are looking at hybrid models of using on-prem solutions, using machine systems on the cloud. So that hybrid architectures are emerging, and I think the compulsive need driven by say reg tech at times to have data within the premises, have data, and the other business aspect would be that you want to leverage on the data for your benefits rather than export data and import intelligence. I think that's the way that these data centers are now developing. The backdrop of all of this, we spoke about the power and the other capabilities in and around the data center itself, and so that's causing a lot of change for organizations in the way they looked at their IT infrastructure and where they want to house their IT infrastructure. The other attribute I think that falls right into this entire scenario is the expanding edge footprint, if you were to look at it, because 60% of your data is going to land on the edge. The more devices on the edge today, so your ability to handle your data, your ability to send insights across the board means that you have your capability across the board. So how do you do that in a hybrid way from an edge to cloud infrastructure is really the thing.
Thank you, Mr. Sadashiva. We have Mr. Manav Bakshi with us. Welcome back, Mr. Bakshi. I'm just going to take about 15 odd seconds to introduce you to our gathering. I did not read out your introduction when we began the panel, and then I'll call upon you with a question that I would want you to respond to. Mr. Manav Bakshi, as I said, is Senior Vice President, ANZ Bank. He comes with more than 20 years of experience in transformational engineering and enterprise modernization. He has a proven track record in driving modernization across infrastructure, applications, and data, while building and scaling global support models, embedding automation, and shaping data strategies that deliver lasting business value. Mr. Bakshi, very, very happy to have you here. My question to you is almost, yes, my question to you is almost similar in terms of, how do you perceive this whole, advent of AI in the data center landscape? But before that, I also want to understand that from an ANZ's perspective, how are you typically looking at data center operations? Are they captive? Are you, leasing out some capacity at the co-location player? And what are your plans?
So, first of all, thanks, Akansha, for such a nice introduction. Am I audible?
Yes, so you're audible.
Yeah. I cannot tell you ANZ landscape about data center and how we are progressing. We are a bank, so we have to be secretive. But having said that, I've heard a lot of speakers talking about AI-enabled data center and everything. So what we are looking for as from a user point of view is data centers, which has which is definitely having intelligence embedded in it, and data centers which has a lot of solutions with respect to intelligence in terms of performance data, how we can speed up our workloads and things like that. Having said that, we are migrating towards AI-enabled data center in our head office point of view. I can just share that much. And we are looking for a lot of solutions. For example, people are talking about hyperscalers, cloud solutions, hybrid, private, and all that. So we want data centers to be ready, where data centers are ready with observability and built in it, intelligence built in it, so that we can just go ahead and plug and play. The assets are discoverable. The life cycle has been taken care automatically as they are AI enabled, and data is secured with all sort of guardrails around it, which is respect to AI, using it with governance. That's what I want to say, Kanchan.
Right. Thank you, Mr. Bakshi. Let me move on to Mr. Saurabh Gupta now. And Mr. Gupta, my question to you is more on, as the world prepares for a smart infrastructure, AI-ready infrastructure, right? One, if you could also delve a little in terms of what are the forces that are driving the need for the infrastructure to be AI ready. But at the same time, if you could tell us that what are the key components that, will help a data center become, will become AI ready or embrace that AI readiness.
Sure. I hope I'm audible.
Yes, so loud and
Okay.
clear.
Good afternoon, everyone, and thanks for introduction, Akansha. So I'm happy to be part of the elite group. Thanks for me. When we talk about AI-enabled data center, everything what I think of, it boils down to a single word. It's real time. Now, we have been developing applications for ages. Now, we don't want to develop application just to process the data. We want applications to understand and act on it immediately. There are many live examples in our cases in our day-to-day life, like we do multiple financial transactions. So our colleagues and the panelists and elite panelists have told. So let's say if we are doing a transaction, it has to be detected if there is a fraud. It has to be detected within the milliseconds. We don't have even the minute to detect for it. We are talking about the self-driven cars, where the data from the sensors, I'll say the cameras and the sensors are fed every millisecond, and the action has to be taken every millisecond. You cannot delay it. But when we talk about data centers, we generally get into the algorithms, the models of the data center, the data lakes, and all. But as all panelists have agreed that we should have a high performance physical layer also. For any AI enabled data center, high performance data physical layer is much more required. The common thread of intelligence is only as good as the network feeds the data to AI enabled data centers. It's the physical layer cables and the connectivity in the data center, which introduces, even if it introduces a microsecond of latency or a single layer, the entire AI model fails. The delay means a fraud goes on or the car cannot react on time, in both the scenarios. So it can be fatal. So for me, thinking about AI-enabled data center, the must thing to have, what my colleague has also told, is about the pre-terminated connectors and the solutions what Belden can provide into. So that's must, because it can eliminate the on-site errors, and it can also speed up to come up with a new data center.
Thank you, Mr. Gupta. I'm going to go to Mr. Dhavle now because I think he has a hard stop at 4. But Mr. Dhavle, in your remarks, you of course spoke about, you focused on cooling. And as Mr. Rupesh was saying that, typically the AI transformation, there are 4 things or 4 pillars in terms of rack density, power, cooling technologies, and network. If you could also speak a little or, tell us your experience in terms of how the network needs and requirements need to be taken into consideration when you're looking at that AI readiness or shift towards AI infrastructure.
Okay, so see, basically, when we talk about the AI load, okay, there are two types of the AI loads currently talking about. One is the training modules, and another is AI database, okay, which will be serving to the different services. When it comes to the training modules, generally the data will get at one location, at a hub locations, and the requirement of the network may not be substantially high, because the training modules will be working and analyzing on the data to bring the output. But when we talk about the AI load, where it is going to serve to the different services which mostly the hyperscalers will be bringing, I feel that the next advance or next expansion which will be happening is between the core data centers and the edge data centers. So that is nothing but we are talking about the CDN network. So we have parallelly seeing that number of edge data centers are increasing across pan India. So currently, being I'm sitting in Nextra, so Nextra is having the largest number of edge data centers and also having the core data centers. So from the core data centers, the maximum load will get transferred to the edge data centers as per the demand coming from the eyeballs. So content to the eyeball connectivity will happen through the network, and this network need to be more strengthened, okay, with the redundancy, uptime and availability at the lower latency. So we see on the network side, now earlier we were talking about 10 gig or 100 gig. Today in the metro cities 400 gig bandwidth is available, and that is getting transmitted or currently is getting used also for the OTTs as well as for the hyperscalers. But if we really look the penetration of that network up to the last mile level and into the tier 2, tier 3 and tier 4 cities, it is still long way to go, or there are a lot of things are happening, means lot of new connections and new man and LLD sites are coming, but it will take little more time. At the same time, the penetration of our 5G network, and if possible the 6G which is coming, and the Starlink which is coming in India, that is going to bring a lot of network related advantages in the data centers for connecting between the core and edge, Akanksha.
Right. And Mr. Dhavle, if I can just ask for your brief remarks, you spoke about edge data centers, and of course, Nextra is one of the companies that has quite a distributed network of that. What's your take on the overall development of edge data centers in general? I mean, I remember that about a decade back, we had some very promising, projections there, but I don't think the edge DC ecosystem has taken off the way, we would like. So any particular issues, maybe a brief response will
Yeah,
work.
yeah, yeah. Very briefly. See, basically, mainly the telecom players like Airtel or other same in line are using their MSC locations, okay, or the small NLD and man sites, okay, as a edge locations currently. If you ask me, that is really serving to, yes, today the kind of demand which is coming from the eyeballs, this kind of services are meeting the requirement. Today Nextra is having total 164 edge locations, and it is growing every month, every quarter, okay. This is serving to the requirement, but definitely in the very near future, rather than hosting the services from the MSCs or from the telecom sites, there will be a dedicated edge data centers will be coming with a capacity of around 5 megawatt and expandable up to 10 megawatt. So that designs are also coming very soon.
And Mr. Thavri, this is going to be my last follow-up question. I saw that you've already, responded to a couple of questions from the audience, so we won't take more for you, and we can free you up by 4. But this is a follow-up question. As you said, that not only Nextra, but a lot of other big DC players are also looking at core facilities and then edge facilities. So when we look at AI coming and you prepping your core facilities up to manage those HPC workloads, etc., do you have to bring in some sort of changes from a network or a design point of view in the edge deployments also, or the way you've planned them initially, they can just be scaled up to cater to more AI workload?
Both are possible because see, when I talk about the telecom site,
Mhm.
okay, or POI locations, okay, having the expansion capability, we are definitely going ahead with these expansions, okay, to making those ready for the AI workloads. Fortunately, having a very strong backbone of Airtel, we have an excellent connectivity to all POI locations. So definitely we could able to serve to those hyperscalers as well as the many OTT players. Okay, and yes, means very near future this edge footprint across pan India, right from tier 2, tier 3 and up to tier 4 cities is going to increase, and that is the plan of the Nextra going forward.
Thank you, Mr. Dable. I'm going to move to Mr. Sadashiv now. And Mr. Ranganath, if you could just tell us about, a little elaborate on HP's role in the entire, data center ecosystem, and what are your focus areas when, you talk about AI-ready infrastructure,
Yeah, as I started off saying, if you take the word data center itself, you're essentially building a lot of infrastructure in and around data. So one of the foremost pillars in the strategy that we bring to table for a data center is centered around how do you handle data. And data has a life cycle. You essentially create, manage, and also protect your data. So that entire life cycle is what we do with our set of products in the data storage space. And then there is the compute aspect of it, which is the arrowhead of any kind of transformation that we are seeing across the board, right? So compute also is very layered in the sense that you have industry standard compute, which is running on typical processing capabilities. You have now accelerated computing, which is running on GPUs. You've got high performance computing, which is running on a cluster of GPU CPU combinations. So there is an entire gambit of compute power that's there to harness. And one of us told about the real time capability requirements. So when you need talking real time, you're essentially wanting that kind of compute power backed by the data that's behind it. And especially in an AI driven world, you're essentially talking of data of various types as well. It's not only the structured data that was available through typical application that we're all aware of. You're essentially now trying to harness a gambit of other types of data that's available, be it file or object. So your ability to ensure that the data is AI ready becomes very important, and also making it ready for AI consumption is also an important task, right? And all of that, where do you find the insights is a big question. And you'll have to ensure that we are always ready to deliver that. Not to forget the overall networking part of it, which includes physical connectivity of the devices that's there, but also between the storage and compute requirements that you have. If you're talking of GPUs, and we spoke of, and the presentation saw the number of cable connects that you need to drive the data across the various components in an AI cluster. Your ability to do that is where we are all focused on. But if you look at AI, and many a times we speak of the inability of AI to deliver on an ROI, and a lot of organizations coming to say that POC and scaling beyond POC is getting difficult, is a factor that we are focused in a very siloed way, I would say. You're essentially looking at one or two use cases and trying to deliver a lot out of it. Whereas for AI readiness, you need to have a platform capability. Your strategy should deliver to an AI platform which is able to harness data in various types. Your use cases are very transient. You'll have that come and go, and it will change over a period of time as well. So in that context, if you have the platform which has the right kind of data, right kind of compute, right kind of networking, you could pick whichever model you want. People said it was a large language model that was needed. Now they're saying you need a small language model, and people are using two or three models to come out with an option that they want. So your ability to deliver to a platform and then use various use cases becomes very, very important. And we are focused on delivering that capability. One, within your premises, which becomes a private cloud, AI capability that you bring to the table. Many of them want that today because they see they have to comply to the legislations. They want performance. There is cost factors when you're looking at hyperscalers. And also, as I said, AI itself is a hybrid workload. And when you're making use of your data for training and stuff like that, there's no need to move that data up and down a cloud infrastructure. So people are looking at how that can be optimized and how you can do that. So that's an area that we focused on. And about the data center is it's all about bringing these technologies together alongside power and cooling. And how do you ensure that power and cooling is done effectively? How do you look at that? Whether we talked of cooling using fans, that's now going away. You need liquid cooling. What sort of liquids needs to be used? So we are a lot of inventions in that space as well. So all in all, if anybody is looking at delving on their AI strategy seriously, which is where the market is headed towards, they will have to look at some of the technology options that we bring to the table. And it is an holistic approach, I would say, in terms of integrating with several technologies to ensure that the customer delivers on the promise of AI, and also delivers with a sense of sustainability, which is another factor which we might speak a little later. But is also important to look at how sustainable your designs are. and then getting the right kind of return on investment, Akanksha.
Right. And Mr. Sadashiv, if I can just have a follow-up question here. I mean, you've elaborated in terms of what should be the key components as, AI becomes more complex, and this is how the networks need to be ready. What are the key challenges that you think are going to be the roadblocks for them to do like a seamless, transition to this era? Any particular challenges that you
Uh,
point in time?
yeah, I mean, technology is not a challenge. I can say that to you. In terms of really looking at AI and implementation of AI for the right kind of use cases is has been a big challenge. I also see that there's a sense of AI maturity that customers needs to develop over a period of time. Most of the efforts in the AI space today has happened very arbitrarily in the sense somebody is just doing a bot kind of a solution which perhaps is not integrated into the overall main system, and it's kind of an AI project but means nothing in the context of an organization. So that's a big challenge that we see. Infrastructure, when you're speaking infrastructure here, the availability of the right kind of power and cooling resources, and also in terms of the data center capabilities of organizations, is something that's an important concern as well. It's only now that you're seeing a lot of options being made available. If not, which is also getting consumed very quickly, as I know, because people who are interested in investing in the AI infrastructure piece for themselves are wanting they don't have the right kind of power and cooling requirements, and the data center has to transform significantly. What do? You either build one for yourself or you look for options across the board, and that's where there's an opportunity for data centers to grow. And as I said, fundamentally there is a shift in the way you build a data center. That's going to change as we move on into different kind of technologies. So your ability to build something that's agile, composable becomes very important, right? I think these are some of the issues that we see apart from the skilling ones and stuff like that. But all in all, that entire awareness within the market space in India has grown in the last 6 months, and the conversations are more mature. People understand it's not a magic wand. It is an iterative process. It is a strategy that one needs to adopt to. And there's no, quick remedies to this. You have to go through this.
Thank you, Mr. Sadashiva. We're going to come to Mr. Rupesh Kumar now. And Mr. Kumar, my question to you is that, SIFI, of course, has a very long legacy of, operating data centers. And if I may say, the data centers have stood, they've stood the test of times in terms of technology evolution also, right from probably decades back when the first facility
45
must
years.
have come up. So, Mr. Kumar, my question is that now when you actually look at your facilities, core facilities, looking at making them AI ready, what kind of challenges do you, face? And if you can probably focus more on the network side of it, smart infrastructure side of it, and in future, when you're looking at building AI ready capabilities or AI ready facilities, what are the, key guidelines that you're keeping in mind?
Yeah, so we are already on that path. Okay, so we are already in that path, and we have kind of realigned all our design philosophies based on that, which we call it as our Generation 3 data centers designs, where we have looked at these things. And then, as I mentioned about the four aspects has been already been considered. And we are also kind of designing our facility based on a pod architecture that is kind of a fixed power capacity modules that can be replicated, on need basis. That will kind of scale up your facility into multi-megawatt capacities based around the growth path. So that is one major aspect which we have considered in our design that is helping us to kind of scale up our facility from a smaller scale to a megawatt kind of a campuses. That is one thing. And other thing is on the operations part. As you mentioned about 25 years of operations is not a small thing, right? So we have kind of learned many things in that. So now what we have also done is that our operation framework that includes newer technologies, and we have also kind of adopted the AI assisted operation tools for that. So for example, our CMMS or BMS, which is kind of an AI assisted one that is kind of helping our operations team to kind of take decisions, and then they get all the information on their face. And also our command centers kind of we call it as a global command and control center, GC3, which is kind of an interconnected tricentric data centers that is kind of supporting all our data centers in India. And with all these AI tools enabled. And other one is your edge and the edge data centers. So see, the edge data centers are now no more an MSC, or kind of supporting a network centric, or where you have some kind of an aggregation switches or a network switches there, and then probably some cache servers. Is not that. So edge is kind of changed now. So the edge has become kind of a compute center also now. So it is nothing different from a core data centers. It is maybe a scaled down version of that, but then that doesn't dilute any of the specifications of an edge data centers. So, for example, the one which we are going to launch this month and the next 6 to 7 edge data centers, which we are launching in the next 8 months, will have this new age edge data centers that will have the right combination of network and computing, even supporting the AI workloads in these edge facilities. So that's a kind of a designs which we have done now. And of course, it is supported by our power infrastructure. I mean, in the sense, as you know, that all these data centers which has to scale up should need kind of a power in like an on-site substations kind of a thing. So that's also kind of done there. And of course, network. A network we looked at actually two things. One is your inter building or intra building kind of a network in a campus, and your national network where you connect all your multi-city data centers with a high speed and high reliable network. So these are the factors which we are already kind of considered in our things, and we are also evolving, based on the industry demands.
Right. And Mr. Kumar, I think you've partly answered the question that I'm going to ask now. But SIPI has more than 400 megawatts operational capacity across, I think, for 13, 14 data centers. Do you have a kind of bifurcation? I'm not sure if that is even available, where you say, okay, this much of megawatt capacity is AI ready or has already advanced to AI, and this is the kind of bifurcation that we are looking at when we are also looking at the future capacities that are either underway or planned.
Yeah, so we see, for us, we don't really differentiate in that way. But when you look at all our Gen 3 data centers, that will contribute around 50 to 60% of this capacity, what you mentioned. That is kind of an AI, workload enabled data centers. So all our Gen 3 data centers, like in our Noida or Chennai or Mumbai campuses, they all are kind of supporting these huge workloads, and they all are kind of huge campuses, each building supports around 40 to what kind of a capacities. So that's a kind of a campuses what we call supporting this kind of a large AI workloads. And other one traditionally supports all our enterprise kind of compute requirements.
Thank you, Mr. Kumar. Mr. Verma, if I can request you to switch on your video, and Mr. Gupta, I'm going to come to you after that. So basically, there was this one question from the audience which said that how difficult it is to, migrate a traditional DC facility to an AI DC facility. You, of course, have responded to it, but I just thought that, for the greater good of the audience, you can probably just quickly tell us about how difficult or easy it is to do that.
Yes, Akanksha. So during our presentation, we had a slide discussing about the density requirement and the bandwidth requirement for the AI DC. In the traditional DCs, our backbone, we were happy with the backbone of 10 gig. And when we were designing it, we were designing it a way that later on we can migrate it to 40 or 100 gig without changing the infrastructure from the cabling perspective. But data center for the AI start with 100 gigs, and you need to migrate later on to 400 or 800 gigs. So the cables and connectivities are different. When I say cables and connectivities, I mean to say the solution approach. So earlier, sometimes in the traditional DC, you may have some places where people are literally doing splicing for making the fiber links, which is not at all recommended in the DCs nowadays. You will have more losses. So there will be pre-terminated solutions. There will be a MPO8 or MPO16 kind of connectivity solutions. So you cannot, you need to change the entire infrastructure from the cabling perspective. Then if you move to the copper part again, in the traditional DCs, we used to have only category 6 cable, which has a low bandwidth and speed requirement. In the upcoming or the new DCs, you have a high bandwidth, 10 gig or higher. You have application for a longer length. So the infrastructure needs to be changed. It's not that easy from the cable network infrastructure point of view. That's what I can say as of now.
Thank you, Mr. Verma. Over,
Uh,
moving on.
Akanksha, I
Sorry,
just
yes.
want to add a
Yes,
point there.
right.
While we spoke of having something that's legacy infrastructure from our perspective, and also AI ready infrastructure that's there, the emergence of hybrid architectures is what we see in market space today. Your ability to coexist with multiple of your investments, right? All a data center that you would have had is something that you would have spent so many millions of rupees on, in terms of building that infrastructure, and it can cater to a lot of workload that you typically have.
Mm,
But there is this AI workloads also, which has bigger demands in terms of all the requisites from a resourcing perspective. So your ability to build architectures that are hybrid in nature and can have a single operating model across both of this existing infrastructure modes that you have is what we are seeing is an emerging technology or emerging requirement today. So people don't feel that they have to desert what they have and then get into a new space and do everything on AI. So there is that mixture, and that mixture is going to grow towards AI, I know for sure. But your ability to handle that without a lot of pain is
mm,
where hybrid architectures help, and you will eventually move on into an AI native design.
mm. Thank you, Mr. Sadashiv. I'm going to move to Mr. Gupta. And Mr. Gupta, Mr. Sadashiva, of course, spoke about, how the two infrastructures have to marry eventually for, to drive success for an organization. And, I want to understand from Belden's perspective that I'm sure you are catering to a diverse set of clients who are looking at building AI data centers from ground up, people who are looking to reconfigure their, let's say legacy systems to be better catered to AI workloads, etc. What is your take there? And how Belden is adapting to these kind of requirements and demands and helping in supporting their customers accordingly.
Yeah, sure, Akansha. So in Belden, what we generally think of providing the performance guarantee physical network, which is the core, or I'll say the nervous system of any AI data enabled data center. For the future scalability and design, the industry, I think, is rapidly advancing towards 400, now 800G, and even we have already started talking about 1.6. My colleague has Abhishek, he has already talked about it. So with this, I think we will start consuming even more fiber per connections. When we talk with our partners or the end customers or the service providers, esteemed service providers, so we recommend to install higher fiber count trunks. So it can be up to 432 fiber cables, which from the very beginning, they can create their own robust dark fiber backbone so that they are ready to cater the need of any AI enabled data center. And this can avoid the constant disruptive, I'll say, the cycle of recabling, which is very tiresome, and it is a costly affair also. So by designing for tomorrow's optics today, we ensure we have a physical layer which doesn't become a bottleneck, but it is easily scalable. And moreover that, we at Belden, we also try to provide the complete stack, intelligent stack with the automated infrastructure solution. So with this, what we try to create a parallel visibility and the control of your physical network. Physical network, when we say it is about the cabling and everything, you will be able to create and provide a live digital twin of the entire network connectivity. This can allow the operators and to have the better uptime, better GPU uptimes, and they may be able to detect where the fault has happened so that they can send their technicians with the required cable or the connectivity, whatever has gone down, without wasting much of the time to detect where and what fault has happened. So it is about automation. This is no more, I don't think this is more a luxury kind of an item. This is a necessity to cater the need. Then
Thank
I already talked about the pre-terminated solution what Belden can offer. So the physical layer, it improves the reliability and the uptime again. So we can avoid the whatever transmission or losses, whatever we had for the terminations done at site. So it can be avoided with a pre-terminated solution, which Belden test. That means every connector is tested in our factory and the plants. So we have plants, two plants in India. Both are equipped to deliver these pre-terminated solutions, whatever we have. So beyond this, we at Belden, we are not only a hardware manufacturing organization. We are building our foundation on the partnership, what I would love to say. And this is demonstrated by the significant investments what we have done in India with these two plants. One is in Kochi, the second one is in Pune. And we are coming up with a phase two of Pune phase plant, which is almost 2.5 times of whatever capacity we have as on date. This is because of the growing need and demand, not only from the data center, but the entire vertical and the India as a region, what we say. So
Uh,
we
no, go ahead, Mr. Gupta, please.
okay. And beyond that, we have also invested into the Customer Innovation Center in Bangalore, which is one of the only 5 globally customer innovation centers, which serves as a collaborative hub to design, test, and validate our solutions, which we have tailor-made it for specific workloads for a specific customer. So it's not only talking about delivering a hardware, it is about delivering a solution to our partners and to our customers.
Thank you, Mr. Gupta. Well, we have about 8 to 9 minutes for audience questions. A whole bunch of them have already been answered by Mr. Rupesh Kumar. We had a lot of questions around power and cooling, and I was about to say that we may only restrict them to network, but Mr. Kumar has been kind to, tell and respond to people accordingly. I am going to first go to Mr. Sadashiva because he's also now responding to those questions. But Mr. Sadashiva, just one question which seemed very relevant, where the question was around, as a CIO, how do you look at balancing costs and, catering to new technology and sustainability? If you could also kind of spend probably another minute or so in, telling it to the entire audience.
Yeah, that's $1 million question. And I basically look at hybrid as a good option to look for solutions in this space. Your ability in a hybrid mode enables you to look at legacy infrastructure and also looks at what's emerging as well. And today there are models available in the market where you can essentially have everything being delivered to you as a service, which essentially means that there's no upfront investment that you had to do, but it's more like the cloud model that's operational to cater to your legacy as well as your future requirements as well. HP has an offering in this space called GreenLake, and it enables you to basically use what infra you have and also kind of deliver to whatever needs you have for future workloads. So it is a combination that's there. And as I said, I think the foundational aspect of any future data center is that it has to cater to the various perspectives of IT landscapes. There was a question I saw around quantum computing as well. So if you look at quantum, it's a different kind of computing again. And today we are doing a lot of research in terms of how you could bridge high performance computing and quantum computing together in a way and fashion that they can coexist. So the relevancy of catering to edge workloads, on-prem workloads, cloud workloads, and quantum perhaps or anything beyond is something that one needs to look at. And that's where you have this cloud management platforms that are available, cloud operating models that are available that enable you to kind of have a single frame of reference to whatever you have and use your resources as you would want. There is perhaps and we spoke of how training workloads can vary.
Right.
Likewise, inference workloads can also vary, right? Your ability to manage and make that as composable and as agile as possible is something that's very important. Thanks to AI, again, we spoke about AI data centers, but there's a lot of AI infusion into the components itself, the way you manage. You have a lot of insights today in the way you manage your data centers, the equipment that you have, which can be AI enabled, and adding the security facet also to this. which is enabled by AI in a very large way today. So you'll have to use AI for your purposes and also AI within the devices.
Mr. Sadashiv, I think you've already taken that quantum computer
Yeah,
question. There's this one more question around where Mr. Giridhar Narasimha Murthy is asking, are open compute project specification-based servers and other components used in AI data centers?
could be. I'm not very sure.
Oh.
At least from what we do, it's basically what we make and sell. So it's not really an open one.
Right. I'm going to move to Mr. Gupta. And Mr. Gupta, somebody has asked about digital twins. I don't know if Belden is looking at, that kind of an offering, or how is it?
So I think he has appreciated. I talked about creating a digital twin about the infrastructure, the physical infrastructure, so that you can have a look about where the fault goes, and immediately they will come to know the operator or the technician can go and deliver the exact material what is required to be replaced, so that we can have a digital twin. So from GPUs to servers to switches, so everything can be visible and it can be monitored also, because it's a vast network what we have in any data center, not only in AI, but in any data center. So it can be done.
Akanksha, we have done digital twins for data centers, especially talking of high performance computing where you have thousands of CPU, GPUs, and multiple components. So there is this is the best way for us to monitor and manage each one of these data centers, because you're able to drill down into all constituents of the data center, be it networking, storage,
Yeah.
or devices within. Without which I think it becomes very difficult for us to pinpoint, what issues are happening, and also we kind of tilt the scale from being reactive to proactive. I think that's
Right.
some of the solutions we bring to the data center.
In fact, Mr. Sadashiva, as Indian infrastructure, we also look at various other, sectors like railways, roads, urban metro, etc. And we've been seeing, digital twins
It's a big
slowly
way,
making their way, at least in the O&M and on the
and
construction.
it's one of the big deliverables in the AI world as well.
Right.
Where you're able to kind of recreate whatever is on prem, and then in a digital world cater to the needs.
Right. We still have questions on water cooling and power coming in. Maybe I'll just refrain from putting this up here. But Mr. Kumar, I have a question for you. Maybe you're the best person to respond. Where somebody has said about mobile data centers in future, which can be movable as technologies and demand evolving. I don't know if they are really looking at literal meaning of movable data centers, or are they looking at,
Yeah, they already
edge
exist.
DCs?
So they already exist. That's the answer. They already exist,
Yeah.
and people are using that. And there are different versions of that depending on the things.
Right.
And predominantly it is used in the defense sector because they have such kind of demands. So there are
Right.
many products around that can be used as a mobile data centers. It's kind of it will look like a simple container or the truck that will have all the compute and everything kind of built into typically a 40 feet container kind of a things, and it can be moved anywhere. You just need anywhere it has to park. You just need a power connection to be given to that. This is an already existing thing, and maybe for decades it's been existing and it's been used worldwide, by various users, especially the mines and the defense sectors. It's a very common thing. Yeah.
Also, to upgrade very quickly, if you were to look at it, right, if you feel that there is a gap in your data center requirements, you can as well do this parallelly, and this can be kind of shunted along.
Yeah, mostly it's kind of used as a transition phase. When you have
Yeah,
kind of a
transition.
migrator thing, there people use it as a
Even add as well,
integrated.
Rupesh. What we see, a couple of installation that we have done is more an additive feature.
Yeah,
It happens in a parallel, and you straight away get into a production mode from day one.
that's right. That's right. Yeah,
Yeah.
yeah, yeah.
Well, I do see a couple of other questions, but as I said, they are around cooling and ventilation. Maybe we'll have another event planned around managing power needs of AI-ready data centers, and we're going to be picking up those questions at that time. With that, I am going to bring this, discussion to a close. Mr. Bakshi, I think, had to leave in between, but he was driving, so I think it's okay if he wanted to focus there. But let me just extend my heartfelt thanks to Mr. Kumar and Mr. Sadashiv for taking out time and for, being with us here today. I'm sure with your remarks, the interactions were very, very, they've become very insightful. Thank you very much to Mr. Dhavle, of course, for just kind of building that tempo in the beginning. And of course, big thank you to Mr. Gupta and Mr. Verma for supporting this event and for also being here to share your insights. Well, with that, I am going to bring this, discussion to a close. Thank you again to all the speakers and of course to all the attendees for, so heartily participating in the conversations. Thank you very much. Thanks.
Thanks,
Thank you very
everyone.
much.
Have a
Thank you.
good day. Thank you.